So the first question here is 68.4 grams of aluminum sulfate is dissolved in enough water to make 500 milliliter of solution. If aluminum sulfate dissociates completely, then molar concentration of aluminum ion and sulfate ion in solution are respectively. So if you remember the question we have done about HCl, ionization of HCl, there we said that 1 mole of HCl gives 1 mole of chloride ion. Here we will see 1 mole of aluminum sulfate will give you how many moles of aluminum ion and sulfate ion. For that you need to write balanced reaction. Balanced reaction will be that when Al2SO4 whole thrice dissociates, and it is written it dissociates completely. So nothing will be left, everything will be dissociated. So it will be twice of Al3 plus thrice of SO4 2 minus aluminum ion and sulfate ions. So you have 2 aluminum, that's why 2 aluminum here. You have 3 sulfate ions, that's why 3 here. So this is the balanced equation. It means the ratio is 1 is to 2 is to 3. 1 mole of aluminum sulfate produces 2 moles of aluminum ion, and 1 mole of aluminum sulfate produces 3 moles of sulfate ion. 2 moles of aluminum ion, 3 moles of sulfate ion. According to this one, we can get the answer because now we just need to get how many moles we have. In 64 grams dissolved in 500 ml, okay, we can calculate the number of moles. Okay. So molarity, basically concentration is asked here. Okay, concentration, it means we need to calculate molarity. So get the molarity of aluminum sulfate. So molarity of aluminum sulfate will be number of moles of aluminum sulfate given mass upon molar mass. Molar mass is given 342. Okay. So moles of aluminum sulfate divided by volume of solution. Moles of aluminum sulfate will be mass over molar mass divided by volume. So we will say mass is 68.4 divided by molar mass 342 divided by volume of solution in liters. It is given in milliliter divided by 1000. So we got the concentration of aluminum sulfate. Concentration of aluminum sulfate, that is molarity of aluminum sulfate, is also written as this Al2SO4 whole thrice. So if anything is written in square brackets, okay, any compound is written in square brackets, it means it is molarity, concentration of that particular compound. So from here you will get concentration of this compound as this much. Okay. So when you solve this one, 68.4, 30, 342 twos are 68.4. It means it will be 0.2, 0.2 divided by 0.5, right? That is 0.4, 0.4. This is the concentration of mole per liter of Al2SO4 whole thrice. But we have been asked concentration of aluminum ion and sulfate ion after dissociation, and after dissociation aluminum ion are double. It means concentration of aluminum ion will be 2 times concentration of aluminum sulfate, that is 0.8 mole per liter. Similarly, concentration of sulfate ions will be 3 times concentration of aluminum sulfate, means 3 into 0.4, that is 1.2 grams per mole. Clear? That will be the answer. That is asked, concentration of aluminum ion and concentration of sulfate ion. For that, you must write balanced chemical equation. Okay. If there is any confusion, just let me know. Okay. Yes, Arjun. Is that clear?
Sir, I had a doubt.
Yes.
Uh, Sir, we write that equation. So, sir, can we do by unitary method that we can find the mass of aluminum sulfate and then we can separately
Too
calculate
lengthy
that?
method with masses. Too lengthy. Okay. So in
Okay.
such cases, calculations in moles, because if we are talking about concentration and molarity is concentration. Okay. You can get the answer in grams, calculation in by doing calculations in grams, but that will be double lengthy method than this one.
Okay, sir.
Now this question is from the uh, concept building part. We have done this question. The molar masses of oxygen and sulfur dioxide are given. 1 liter of oxygen at 25 degrees Celsius, 750 ml, contains n molecules. The question is, in 2 liters of sulfur dioxide, how many molecules will be there? Now, in such questions, basically this question tries to mislead you by giving the molar masses. These are not required. The relationship between the gaseous oxygen and sulfur dioxide, both are gases. Okay. The relationship between the volume and number of particles is very simple. At STP, this is not at STP, but I am explaining at STP, then I'll talk about it. At STP, we know that for any gas, whether it is nitrogen, oxygen, carbon dioxide, sulfur dioxide, for any gas, 22.4 liters will have 6.022 into 10 to the power 23 molecules, or if it is atomic, then atom in that case. Now, at STP, this is the volume, and it says 1 liter will have 6.022 into 10 to the power 23 divided by 22.4. These many molecules will be there in 1 liter. Now, if I change the temperature, okay, then the molecules will change, but in the same proportion. For any gas, maybe if I change the temperature, then in 1 liter, maybe instead of this much, there are more than slightly this one or less than this one. But for any gas, this will be same X molecules at that temperature. So the number of molecules in a constant volume of any gas is constant. We talk about STP because at STP, 6.022 into 10 power 23 becomes equal to 1 mole. That's why STP is important and this figure is important. Otherwise, you need to understand that at same temperature and pressure, I'm writing it so that there is no confusion. At same temperature and pressure, equal volumes of all gases have equal moles, that is equal number of molecules. This is something you need to remember. So if you know this, that at same temperature and pressure, equal volumes of all gases have equal moles, that is equal number of molecules, then this question becomes very easy. It means here the temperature and pressure is constant. We are not changing it. It is written under same conditions of temperature and pressure. It means if at 1 liter, in 1 liter we have n molecules of any gas, in 2 liters we will have 2n molecules. of any gas. So whether it is oxygen, whether it is sulfur dioxide, doesn't matter. In 1 liter, N; in 2 liters, 2N. Yes, yes, correct. So it is not related to the molar masses, it is related to the concept that at constant temperature and pressure, equal volumes will have equal number of molecules. Next question. Before I start this question, just write present in chat box, everyone, nothing else. And once only, not twice. Write present in chat box. The spelling should be correct. Right? Still, what I can see, number of students joined and the responses I have received, still I have not received response from 3 students. Okay. Now this question says 10 grams of hydrogen and 64 grams of oxygen were filled in a steel vessel and exploded. Volume of gaseous product after reaction. So here it is written gaseous product, means only product. It is not written products. Okay. You won't consider whatever is there in the vessel, rather only the product. So if hydrogen and oxygen, for again, as we did in previous question, you have to write the balanced equation. And balanced equation is 2H2 plus O2 gives you 2H2O. Okay. You can solve it by H2 plus half O2 gives you H2O. By this one also, okay? The ratio will be same. The relative ratio will be same. It means 2 moles of hydrogen react with 1 mole of oxygen, and when they are consumed completely, then 2 moles of H2O are produced. That is as per reaction. But what is given in the question? In the question it is given you have 10 grams of hydrogen. How many moles of hydrogen? 10 divided by 2, that is 5 moles. So according to question, you have 5 moles of hydrogen, 64 grams of dioxygen. Oxygen means it exists as dioxygen. So how many moles of oxygen as it exists? 64 divided by 32, that is
2 moles.
so effectively you have 5 moles of hydrogen, 2 moles of oxygen. You need to calculate how many moles of water will be produced. Okay, so here volumetric ratio will be equal to molar ratio. The reason is all will be gases when these react. Okay, these are exploded. You all have as this one as gas, this one as gas. So whatever is the volumetric ratio, that will be the molar ratio. So try to find out whether there is any limiting reagent. Okay,
Sir, O2.
by R, Q by R, 5 by 2, 2 by 1. So 5 by 2, 2.5. It means this is limiting reagent. 2 is less than 2.5. Q by R ratio I have calculated. Okay. In your exam, you will be writing that as 1 mole of oxygen requires 2 moles of hydrogen, 2 moles of hydrogen will require 4 moles of oxygen. So it means 4 moles of hydrogen. So hydrogen is in excess, oxygen is a limiting reagent. This method you will be using for confirmation only, for easily getting which one is the limiting reagent. So limiting reagent you got as oxygen. So oxygen is limiting reagent. It means oxygen will decide the product. How many moles of oxygen you have? 2 moles. And what is the ratio between oxygen and water? 1:2. Means 1 mole of oxygen produces 2 moles of water. 2 moles will produce 4 moles of water, of what, not water, H2O gas. Okay. It means 4 into 22.4 liters volume. Volume of gaseous product. Now, this question
Sir,
itself
I have
is
to
not
ask one thing,
complete,
sir.
right? This question is not complete. And normally this question does not appear like this, what is written here. Normally the question appears, find the amount of the water produced, for example. And the reason is because it is not given at STP. And the question what Arjun you have sent, there is one option, this one, and which is correct in this case, but with assumption that we are talking about STP, which is not written in the question. Okay, so that is an assumption. With that assumption, this answer is correct. Otherwise, answer is this one, 4 moles of
Sir, if
H2O.
if we take it as STP, sir, then the answer will be 22.4 liters.
No, 4 into 22.4 liters. 4 moles will be 4 into 22.4 liters.
Excuse me, sir.
Yes.
Sir, why aren't we considering the volume of hydrogen, sir? Because like after the reaction, some volume of hydrogen will be left unreacted.
Volume of gaseous product. Product is what is produced. So if you read the question, it is volume of gaseous product, not the compounds which remain after reaction. The question is talking about only volume of gaseous product, and product is water only, sorry, steam only in this case, not the hydrogen which is unreacted here. So only 4 moles of hydrogen will react, 1 mole will not react, but we will not consider that because that is reactant, not the product. Is that clear?
So,
Hydrogen is not product, that is reactant. Yes.
sir, in this reaction, won't be there a state chain and H2 is liquid?
H2S liquid, come again.
Sir, in this reaction, sir, H2O sir liquid नहीं होता था, मतलब gas plus
No,
gas
no.
liquid.
When this actually this reaction takes place, in atmosphere during sparking. Okay. Normally, if you mix hydrogen and oxygen, they won't react. You won't get water. Okay. You will get water at very high temperature or when there is a spark. So that spark ionizes, the hydrogen and oxygen, and then water is the steam is produced. So the temperature is so high that it is not in the form of water, it is in the form of steam.
Okay.
That's why if you see the term is written and vessel and exploded. Exploded means the temperature is very high or sparking is done. Yes, any other question?
Sir, can you please tell, sir, how can we use moles for this, sir, stoichiometric calculation? Like, sir, I had done by mass, so sir, I could do it by later dividing it by 18, so I got 4. But sir, how can we directly use the number of moles? Sir, I'm getting confused in this part.
No, I didn't get because I have explained in terms of moles only.
Yes, sir. Sir, actually, what I did was that this 32 gram of O2 produces 36 gram of H2. I did it like that.
Hmm.
Then did, sir, like 36 by 32 into, sir, 64. I did
That
this
is-
thing.
That is again correct. That is not a problem because you will convert that mass to mole afterwards. You will get the mass of steam. You will convert that mass to moles and then moles to volume.
Sir,
So you
but sir,
will
you had also
exactly
told,
get
no, we
4
can
times.
directly use moles.
You can. Basically, both methods are correct in this case.
So, but
You can take
sir, can you please tell how do we use moles in this, sir? Because I have only done this by mass.
Okay, so even if you do through mass, you will say here you have 64 grams, here you have 10 grams. Okay,
Yes,
this is
sir.
given. Okay, according to question and according to reaction, 4 grams 2 is the
32.
atomic mass of hydrogen, 2 into
Yes,
2,
sir.
4.
Yes, sir.
And
And here
here
32.
32. So according to reaction, this one, calculate Q by R, 10 by 4.
Yes, sir. O2 is the limiting reagent
O2 is the
because it
limiting
is
reagent,
2.
right?
Yes,
So
sir.
if O2 is the limiting reagent, you say here ratio, according to reaction, 2H2O means 2 into 18, that is 36 grams water will be produced according to balanced reaction.
Yes, sir.
And 4 plus 32 will be equal to 36. Law of conservation of mass. Okay, so it is correct. You will
Yes.
say as 32 grams produces 36. Hence, 64 given will produce how much? It will be 72, 2 into 36 by unitary method.
Yes, sir.
And 72 grams will be given mass upon molar mass, that is 4 moles.
4. Yes, sir.
And 4 moles means at STP 4 into
Yes,
20.
it's 22.4. Yes, sir. I did by this method, sir. But you had told no in stoichiometric calculation we can also do mole to mass ratio as well. We can involve moles as well in this. So,
You
sir, how
can.
do we do it by that?
In that case, you can do directly. You will say you will say 32 grams give us 2 moles.
Yes, sir.
Okay. So 64 grams will give us 4 moles.
Yes, sir. 2 by 32 into 64.
Yes,
Okay, sir. Okay, sir.
it is 30. 64 is double of 32. 4 is double of 2. It will be double.
So, sir, we could also convert here the 64 grams to moles. Then also we can calculate.
But again, that is complexity. You are creating complexity. Those go into those complexities. Rather, make it simple.
Yes, sir. Okay, sir.
Such questions, it is simpler to do calculations in moles. So this question is slightly tricky because the question is talking about the gaseous product only. And gaseous product is only one, H2O, St. So we will calculate the moles of steam and then we will convert it to volume if required. Otherwise, if the options are not given, this is the answer, or 72 grams, the correct answer. 4 moles of H2O will be 72 grams. Next question, how many grams of concentrated nitric acid solution should be used to prepare 250 milliliters of 2MHNO3 given the concentrated acid is 70% HNO3? Now it is given that 70% HNO3 means if I need 70 grams HNO3, then actually I will have to have 100 grams of HNO3. 100 grams of HNO3 will have only 70 gram actual HNO3. Rest will be water. So question is, how many grams of concentrated nitric acid solution will be used to prepare this? For this, you need to calculate first how many moles are there of HNO3. So from here you can get moles of HNO3 we have. Moles of
That will be
HNO3 will be molarity into volume. 0.5. We have these many moles. Okay. Volume in liters. That's why 0.25. Now mass of HNO3. Mass of HNO3 will be moles into molar mass.
Molar mass 63.
That is 0.5 into HNO3 is 63.
63.
Right? These many grams. We need these many grams. Means we need 31.5.
31.5 grams.
But according to the density, okay, 70% HNO3 means 70 gram HNO3 for 70 gram HNO3, we need 70 gram mass of HNO3. Mass of HNO3, we need HNO3 solution equals to 100 gram. We need to make use of this one. 70% HNO3 means 70 gram will be there HNO3 if total 100 gram solution is there. Okay. What is asked? How many grams of concentrated nitric acid solution? Solution is asked. Okay. So we need to use this relationship. 70 gram mass of HNO3 will be present in 100 gram solution. Hence, 31.5 gram mass, which we need for that, how much mass will be required? That will be 100 divided by 70 into 31.5. That is 3150 by 70. 7 4s are 7 5. 45 grams of solution will be required. 45 grams of solution will have 31.5 grams of HNO3. That will be the answer. Any confusion here?
Sir, can you once again explain the meaning of the question, sir? What it is basically asking, sir?
Okay. It is asking it says if you have 100 gram of solution, HNO3 solution, then it contains 70 grams HNO3 and rest is water. This is what it says. This is given. 70 grams,
Yes, sir.
70% means 70 gram is actual HNO3 in 70 gram solution. Now it says that in what was given, just I forgot, 250 and probably 2. It was given 250 ml of 2m HNO3 will be present in how much solution? This is the question. How much solution will be required? Obviously, a portion of that will be required, in which equivalent to 250 ml of 2m HNO3 will be required. So that's why you need to convert it to moles. So question is about that when you convert it to moles, it will be 0.25, no, 0.5 moles of HNO3 will be present in how much solution of HNO3? Actually,
Sir,
the
I
question,
understood it, sir. Yes, so now I understood, sir. Thank you, sir.
next question. And this one is good question. Okay, this one is a good question, which clarifies quite a few concepts. Although we have used the concept, but it's still good question. What is the OH ion concentration? I told you that if it is written in square brackets means we are talking about concentration, which is nothing but molarity. So question asks, what is the molarity of hydroxyl ions in the final solution prepared by mixing 20 ml of 0.5 mHCl and 30 ml of 0.1 m BaOH whole twice. Now this is acid-base reaction, because here it won't be that you are just mixing. When you mix an acid with a base, there will be some reaction which will take place. So when barium hydroxide reacts with HCl, there will be a salt, acid-base reaction, BaCl2, and
Barium
water
chloride
produced.
and
This is
water.
something you know, when acid and base react, they produce salt and water. And when we balance it, it will be 2HCl. And now is everything balanced?
So 2H2O.
Yes, sir. 2H2O.
2H2. Now it is balanced. Okay. Now it is balanced. Now, according to this reaction, 1 mole of barium hydroxide reacts with 2 moles of HCl. Balanced equation. Stoichiometric ratio. And you can calculate the number of moles of HCl and BaOH whole twice because you have been given the volume and molarity. So according to question, moles of HCl are number of moles, molarity, that is 0.050, this part, molarity, multiplied by volume, 0.020. Remember, volume I have converted to liters because it is given in milliliters. That's why. And barium hydroxide will be molarity 0.10 multiplied by its volume 0.030. That is equal to 0.003 moles, 0.01. 0.052 are 10 and then 001. Is that clear? Now calculate how many moles will react. So 1 mole of this one, calculate if there is any limiting reagent, Q by R. Q by R in this case 0.003 divided by 1, 0.0001 divided by 2. It means HCl is limiting reagent. It is 0.003. This one is 0.00005. This one is much less than 0.003. It means HCl is limiting reagent. So if HCl is limiting reagent, HCl will derive the reaction. And it means some barium hydroxide will remain unreacted. And that will give you the hydroxyl ion concentration. So first try to understand what I am saying. Some barium hydroxide will remain unreacted. HCl will get reacted completely because it is the limiting reagent. HCl is limiting reagent. So we won't have, after the reaction, we won't have HCl. We will have some amount of BaCl2, some amount of H2O, and some unreacted BaHO whole twice, which will give us hydroxyl ion as per this reaction. Balanced reaction. So barium hydroxide, when it will get ionized, it will give us barium ion. So there is one barium ion, but there are two hydroxyls, so two OH ions. For that, we need to find out how many moles of BaOH whole twice will remain unreacted. So for that, you will calculate 2 moles of HCl require 1 mole of BaOH whole twice. Then whatever is given 0.0001 moles will require how much? Half of it. So this is half. This will also require half of BaOH whole twice, means 0.00005. Okay. Just let me check if there is any calculation. There should not be any calculation mistake. Okay. You can do, if you are not comfortable in decimals, the calculations can be done in milliliters also. But make sure that you don't make mistake, you don't get confused between milliliters and liters and substitute the values where it is required in liters. That is the only requirement. Otherwise, you can do calculations in milliliters also. Okay. So 0.05 into 0.02 will be 0.001 because it will be 5 2s are 10 and then 4 decimals 0.01. Okay. So half of it will be 0.0005. It means this much BaOH whole twice will get used. This much BaOH whole twice will be used. I'll explain it again. It is slightly tricky. So, and how many moles you had? So limiting
So
reagent
0.00.
decided Limiting reagent decided that how much BaOH whole twice got consumed. So this much got consumed. Hence, BaOH whole twice left unreacted. Basically, these type of questions will be more clear when we do equilibrium chapter. There we will be doing a lot of such calculations. So initially you had 0.03 and consumed 0.0005, means you have 0.0025 moles unreacted. These many moles you have unreacted. So if these many moles are unreacted, then calculate the ratio. Ratio is 1:2. 1 mole of BaOH whole twice when gets ionized gives you 2 moles of hydroxyl ion. So it means these many moles of BaOH whole twice when ionized will give you double the amount of this one as OH ion concentration. But these are the moles. So how many moles you will have OH ion moles? You have 2 into 0.0025, sorry, yes, 25. That is 0.005 moles. Remember, this is not concentration, this is moles only, not concentration. But we have to calculate moles. For calculation of moles, molarity, sorry, we have to divide number of moles by volume of the solution. And volume of the solution will be sum of the volumes, that is 20 milliliters divided by 30 milliliter. That is 50 milliliter. So how you will calculate? You will say volume, first I am writing moles. Moles of OH ions, we have calculated 0.005. Volume of solution, 30 milliliters plus 20 milliliters, that is 50 milliliters, that is 50 divided by 1000, 0.050 liters. Okay. It means molarity will be number of moles of hydroxyl ion divided by volume, that is 0.1 mole per liter. No, Arjun, we didn't judge like that. We just compared the stoichiometric ratios and we found that HCl is limiting reagent because HCl is not in required quantity. HCl is less than the required quantity. So there is nothing related to that OH ion was unreacted. As HCl is limiting reagent, from that we found that OH will be BaOH whole twice will remain unreacted and we will have OH ions after that. So it is reverse that. Just let me know why there's that confusion.
Sir, since the question has already mentioned the amount of OH ion, so sir, it is quite obvious, no, it is from BaOH2 only. So because OH ion is not present in any other reactant.
That's fine. But how will you find how much BaOH whole twice will remain unreacted?
Okay, sir. So means it could be that HCl is the limiting reagent, then the answer would be 0.
In few cases, yes. In JEE main questions are tricky one. So in that case, yes, answer can be 0. Okay. So it is not necessary that if it says that BaOH whole twice OH OH ions are there, it is necessary that HCl will be limiting reagent. Okay, you need to check whether HCl is a limiting reagent in reality or not. If HCl is not a limiting reagent, the concentration of OH ion will be zero in that case. And in this case, because HCl is a limiting reagent, some barium hydroxide will remain unreacted, and that will constitute to double the moles of hydroxyl ions. So you will first get the number of moles of barium hydroxide unreacted. Those will create the double the numbers of barium hydroxide as hydroxyl ions. So from there, you will get the number of moles of hydroxyl ions as double, and then you will divide that by the volume of the solution to get the concentration of OH. So this is actually OH ion concentration is 0.10. Next question. 1 liter of carbon dioxide is passed through red hot coke. The volume becomes 1.4 liter at same temperature and pressure. The composition of the products is. Now in such questions, you again need to know the reaction. When CO2 is reacted with carbon at red hot temperature, it gets converted to carbon monoxide. Okay. So this is the balanced reaction. And according to this reaction, it is given, initially it was 1 liter and we didn't have any amount of carbon monoxide produced. Even if this was present, it didn't react because initially no reaction is there. So initially only carbon dioxide was there, but after reaction, this was 1.4. The volume becomes 1.4 liter. If volume becomes 1.4 liter, then it means some amount of X got reacted. Now you need to understand what is the ratio of reaction. 1 mole of carbon dioxide reacts with 1 mole of carbon, and when they are consumed completely, they produce 2 moles of carbon monoxide. Okay, 2 moles of carbon monoxide. So if 1 mole of X reacts with 1 mole of carbon, means if X moles of carbon dioxide react, they will react with X moles of carbon. This should be very clear. So if I'm writing as X moles say react with X moles of carbon dioxide, they will produce 2X moles of carbon monoxide. This is what we know as per the reaction. But if X got reacted, means 1 minus X remained. Okay. So after will be 1 minus X. Initially 1 was there. So 1 minus X was there. Okay. And volume is written here. Volume. Okay. And volume will be of gaseous products only. And this is 2X. This is solid. So this is gaseous. This is gaseous. This is solid. It means sum of these two is equal to 1.4 liters. Understand this point very clearly. What I'm
Sir,
saying.
please explain this again.
Yes. Initially, you had 1 liter of carbon dioxide before reaction. So up to here, is that clear?
Yes, sir.
Okay. After that, X got consumed. Here also X will get consumed because the stoichiometric ratio is 1:1. So both same amounts will be consumed. The stoichiometric ratio is 1:1. So if X amount is consumed of carbon dioxide, X amount means moles, X moles of carbon will be used. And here we have 2 moles as per balance reaction. So 2X will be produced. So why I have written minus here? Because reactants are consumed. So minus. products are produced, that's I plus. Is that clear up to here? Or any confusion?
Yes, sir.
Okay. So if it is clear, then if out of 1 x is consumed, how much will remain? 1 minus x. After the reaction, how much carbon dioxide will be there? 1 minus x. X got consumed. And how much carbon monoxide will be there? 2x, because 2x got produced. So after the reaction, there will be carbon dioxide 1 minus x and carbon monoxide 2x. Volume are given, so that's why we won't consider carbon. Carbon is solid. Okay, carbon is solid. So we will not consider volume of this one. Obviously, this will be some part remaining there, but this will be, we have plenty of this one and we are not bothered about it. I hope it is clear why I am not talking about this one carbon, because the total volume is 1.4 and volume will be constituted only by carbon dioxide and carbon monoxide. Gaseous volume. Solid will not have any gaseous volume. So it means sum of these 1 minus x plus 2x will be 1.4 liters. Means 1 plus x equals to 1.4, x equals to 0.4. So value of x, we got 0.4. So it is asked, what is the composition of the mixture? So composition of the mixture, 1 minus x is carbon dioxide and carbon monoxide 2x. So CO2 composition is 1 minus x, that is 1 minus 0.4, that is 0.6. Composition of CO 2x, that is 2 into 0.4, that is 0.8 liters. Is that clear?
Yes, sir.
Yes, sir.
And if anything is not clear, go to the website, watch the video again. Okay. Now last question today. In Haber process, 30 liters of dihydrogen and 30 liters of dinitrogen were taken for reaction, which yielded only 50% of the expected product. What will be the composition of gaseous mixture under the aforesaid condition in the end? Haber process is a production of ammonia, which is nitrogen N2 plus 3H2. They give you 2NH3. Now, as per reaction, if I am talking about, as per reaction, if I have 1 liter of nitrogen and 3 liters of hydrogen, when they are consumed completely, they will give me 2 liters of ammonia. Okay. 1:3:2 ratio is there. 1 is there, not written. So it is 1:3:2. So we know this relationship. 1 liter of nitrogen will react with 3 liters of hydrogen and will give 2 liters of ammonia. So if I have 30 liters of nitrogen and 30 liters of hydrogen, how much ammonia will be produced? First of all, I need to get that. And then I need to talk about this, only 50% of that. Okay. So first I need to find if there is any limiting reagent. Yes, there is limiting reagent.
H2 will be the limiting reagent.
Trojan.
Okay. So I will calculate Q by R. 30 by 1, 30 by 3 means 10. So hydrogen is limiting reagent. If hydrogen is limiting reagent, hydrogen will decide how much ammonia will be produced. So hydrogen is limiting reagent and will decide the amount of ammonia produced. Okay. So 3 moles, according to reaction, 3 liters of hydrogen produce 2 liters of ammonia, 30 liters will produce 20 liters.
20 liters of ammonia.
20 liters of ammonia. Direct unitary method. Hydrogen decides 3 liter produce 2 liters, but I have 30 liters. So 30 liters should produce 20 liters. But question says it is only 50% of the expected value. It means instead of 20 liters, we get only 15 liters. Sorry, 10 liters, half of it. 50% of expect. We got only 10. Now, how can we get 10? 10 will be produced by how much hydrogen? 15 liters of hydrogen would have been used. Apply the same logic. 20 liters was produced by 30 liters of hydrogen. Okay, 10 liter will be produced by 15 liter of hydrogen. Is this clear or not? I am applying just unitary method.
Yes, sir.
Okay. And as per the question, 3 liters hydrogen requires 1 liter nitrogen. It means 15 liter will require 5 liter nitrogen. So 5 liter consumed, 15 liter consumed, 10 liter produced. It is, if you see ratio 1:3:2, which is as per reaction. 1:3:2. So this is consumed and this is produced. Question says, what will be the composition of gaseous mixture, not product, the entire mixture? Means nitrogen, hydrogen, ammonia. So ammonia produced, yes, you got 10 liters. So this is the answer, one answer. And 15 liter hydrogen used. So how much remaining? What will be the composition of hydrogen? 30 minus 15, that is 15 liter left. The question is talking about the composition of gaseous mixture after the reaction in the end. So 15 liters of hydrogen will remain unreacted. Similarly, now find whether there will be nitrogen unreacted. Yes. 30 minus 5. 5 got consumed. 30 minus 5, that is 25 liter left. So at the end, you will have 25 liters of nitrogen, 15 liters of hydrogen, and 10 liters of ammonia.